My name's Mike Owen, and I'm the aquatic ecologist on the Monongahela National Forest here in West Virginia. So the Monongahela National Forest, we have about 1 million acres of land that we manage in the north central portion of West Virginia, which includes the Central Appalachian Mountains. We have over 1,500 miles of stream on the forest, and that represents about 90% of the trout waters in the state of West Virginia. In addition, we are the headwaters of 6 main rivers, so we are a very important resource for downstream users of water quality. For the program that I manage, the Watershed program, a lot of what we're doing is watershed restoration work. So we're trying to take care of some of the things that impair watershed health in our systems.
One of the biggest pollutants probably in our watersheds in this area is actually sediment. And the majority of that sediment pollutant is from roads. So it's from erosion from roads, especially roads that aren't maintained.
On the hill slopes, in the process of cutting into the soil profile, what you're doing is getting down into the groundwater. So you're taking water that would normally be in the soil, moving gradually down, coming out as cold water springs, and instead bringing it to a road, heating it up, putting it into a ditch, accelerating its movement down and out of the watershed.
Watershed by watershed, we go through and we look at the roads. If they're no longer needed for forest management, we'll try to decommission those. And so that's taking that road off of the system. That is no more erosional risk for that watershed.
This was a pretty steep road coming down the slope here. It was funneling runoff and sediment just right into this nice trout stream here. And by decommissioning, decompacting, outsloping, the rainfall gets absorbed in the soil, released more slowly at a cool temperature over a longer time, and this will become a natural riparian corridor along the stream.
This road that we're on right now was decommissioned about 6 years ago. What we found that by far the native vegetation from around the forested area just repopulates that area really quickly. So even within the first growing season, we have a really great cover of the native plant community that comes right back in.
For me as a soil scientist, I think road decommissioning is a great strategy at making headwater systems more resilient for a changing climate. If you have an intact watershed where your soils are functioning and have high soil quality, where they're able to hold water in place, have a slow release of that water through into the streams, that water stays higher in the system, higher in elevation, remains cooler over time. And therefore, as the climate changes and storm frequency is higher, rain events are higher in precipitation, you have an intact watershed that it can act like a sponge to hold that back. And the more we can hold water back in our headwaters, the less response we see in downstream flooding.
In low flows, the storage of the water within the soil is also impaired. And what we're trying to do is we're trying to keep as much low flow water as we can, because that's the critical period for trout and other aquatic organisms. If there's no water in the stream, there's no aquatic habitat. If we can keep some water in the stream, because we've slowed down the runoff, we've done a good job of creating resiliency for climate change, creating permeability for creatures that are trying to make it upstream. And for our trout, it could make a significant difference.